Use Stokes' theorem for the vector field f x y z, where it equals zi 3xj plus 2zk, where s is the surface, z equals 1 minus x squared minus y squared, z is greater than or equal to 0, and c is the boundary circle, x squared plus y squared equals 1, and s is oriented in the positive z direction. So the first thing we're going to need here is Stokes' theorem so that we will be able to see what we need. So here it is. So now we have two choices. We can say, hey, let's go with the left, where I just got to find an RT and I can set up my integral that way as a single integral, or let me go with the area of that surface and use a double integral in the curl and the normal to come up with the integral for this. So we're going to try the latter. We're going to go with the second one. We're going to find the curl of f. We're going to do tu cross tv. We're going to have some fun with this one. So that's the way we're going to go. So first, I always like to start off with the RUV. So the RUV is going to equal. Now, when I look at this surface here, the first thing I think of is cylindrical coordinates. So I'm going to go that way. I'm going to go with cylindrical. So then I can say my u is theta and my v equals r. So then for my first component here, it's going to be v cosine u and then v sine u. Now, a lot of times it doesn't always work out this way where I'm finding for my z, but for this one I definitely am finding for my z here. So I'm going to use the equation that I started this with a slight modification. All I did was factor the negative out. If you look at the original equation, that's what it is. So this is really z equals 1 minus r squared. And remember, when we started this, I said my v equals r. So that tells me then that z equals 1 minus v squared. So I can just write that in there, that 1 minus v squared. So there's our RUV. Now let's talk about the boundaries of RUV. So the first one, my u, since it's theta there, it's going to be 0 to 2 pi. And then for my v, this is where things get a little interesting because I have to do a little bit more work for that. So when I look below here, it says C is the boundary circle, x squared plus y squared equals 1. Now, they didn't have to give this to me. What I should notice is that this is opening downward, and it's shifted up 1. It's a paraboloid. And my z equals 0 is my lower bound there. So if I plug in a 0 here, and I move the x and the y over, or I should say x squared, y squared over, I would get exactly this equation. So that's why I say that. We don't necessarily need that information. And that tells us then that x squared plus y squared equals 1. So x squared is r squared. X squared plus y squared is r squared, I mean. And then if I simplify this, my r equals 1. So my v goes from 0 to 1. So now what we're going to find is our RU cross RV. I'm just going to write those out, and we're going to get started with those. So for my RU, this is going to be negative V sine U. Oops, let me write that better. And then for my middle component, with respect to U, that's going to be V cos U. And then for my third, it's going to be 0, because it's with respect to U. There's no U's there. Okay, now the second one, RV, I'm going to get cosine U, comma, sine U, comma, negative 2V. All right, we want the cross product of those. So that's going to result in. So now I can clean this up a little. If you need to pause it and look at the values, make sure they match up with yours. So minus 2v squared cosine u, this is going to be minus 2 or negative 2v squared sine u. And then the last one here, I can pull a negative v out of both those. And I'm going to get sine squared u plus cosine squared u. And that's going to be a 1, so I'm going to get a negative v there. So So this is my RU cross RV. Now I drew the picture here because I want you to see what is going on with our n, because RU cross RV is actually our n. And it said here that S is oriented in a positive z direction. So that means my vector should be coming up in this direction. And if you notice, I have all these negatives on my vector here. So that tells me that should change. I should negate it, and then it'll give me all positives. Actually, I have this vector going on here, and I don't need that one. I need it to go in the other direction. So since the positive z direction is where it's oriented, then that means my n is going to have to change here, and it should just be all positives, because when I negate them, they all become positive because they were all negatives. So now what we're going to do is now we're going to need our curl of f of our uv. So that's what we're going to do now. We're going to find that piece. So we need the curl of f. So if you didn't catch that, we're going to need the curl of f. All right, so we have f, which is z 3x 2z, and we need our partials. And then for my ry, this is my p, this is my q, this is my r. So then for ry there, I'm going to get 0. For qz, I'm going to get 0. For pz, I'm going to get 1. For rx, I'm going to get 0. For qx, I'm going to get 3. And for py, I'm going to get 0. So now that means my curl of f is just going to be 0 minus 0, which is 0, 1 minus 0, which is 1, and then 3 minus 0, which is 3. So there's my curl of f there. So now I need the curl of f of ruv. But you notice they're all constants here, so it doesn't matter what the u and v are, and I can't really plug them in when there's nothing there to plug in. So there we go. So it's going to end up being the curl of f is 0, 1, 3. So now we're ready to plug everything in and get our answer. So I'm just going to write the double integral down for now. And my curl of fruv is going to be 0, 1, 3. And dotted with my normal vector, which is this one here, we're going to get du dv. And then we're going to put our bounds in. Remember, our u is from 0 to 2 pi. And then our v, and they're right over here, is from 0 to 1. So then this equals the integral from 0 to 1, the integral from 0 to 2 pi. When I take those dot products there, I'm going to get 2v squared sine u for my first one, because that's going to be 0. And it's going to be this one times the second one. So it's 1 times that. So I get this answer here, the 2v squared sine u. And then for the last one, I'm going to have 3 times, v. I didn't go far enough over. So that would be plus 3v, and then du dv. So then our final answer for this, once you do the integrals, it's going to be 3 pi, which is our answer for this integral.